Hello students, good morning to all of you. Today we are going to discuss about another important concept in current electricity. Okay, this is the 11th part, already 10 parts I have given. So now this is the 11th part. In the 11th part I have given, so very important concept that is, so electric energy as well as power. Right? Electric energy and electric power. What is energy? What is power? What is electrical energy and what is electrical power? Right, so what is the energy related formula? What is energy related formula and what is power related formula and what is the relation between electric power and energy? Correct. Similarly, the power in series combination, that means the bulbs or resistors connected in series combination, then what is the electric power? The bulbs are connected in parallel combination, then what is the electric power? So this and all we will discuss in this session. Okay, right. So first the relation, the energy and electric power. The energy and electric power, the relation is given by Joule only. Right, that's what we are entered first, Joule's law. So topic name is electric energy as well as power, but first topic I have given Joule's law. What is Joule's law? What is Joule's law? What he observed? Alright, see once again. What is that? Whenever electric current, whenever electric current passed through a conductor, it becomes hot. It becomes hot after some time. Yes, everybody knew this and all. Right? Okay. This indicates that the electrical energy is being converted into heat energy. Electrical energy is converted into heat energy. This effect is known as heating effect. Heating effect. Heating effect of current or Joule heating effect. Correct or not? So for example, here I have one of a cell. Is the one of a cell. So now here I will give you one resistor. Resistor in the sense here I will give you one of a bulb in this direction. So bulb is having one filament. Filament here now resistor. Tungsten and filament is made up of tungsten only. Therefore this is the good resistor. This is the resistor. So now here we will give you in this direction circuit. When the switch is on, the current is flowing from positive to negative, right? So the charge is moving in this direction. That means this is the flow of current. The current is flowing here. So this is the resistor. Right? Here we observe very clearly. So the bulb will give, what is that? Heating effect as well as light. It will give heat energy as well as light energy. Correct? Now topic is, what is that? Heating effect and light effect. That means brightness. When the bulb will give more brightness, brightness is depends on what? That is the next topic. So now I am speaking about heating effect, heat. Correct? So the flow of, that means this heat energy is given by, so cell only, right? Correct? The cell only. That's what here we will say, the work done by cell. The work done by cell. That means heat energy is dissipated like that only. Okay, now heat energy is going in this direction. The current is going that direction. Yes or no? The current is flowing in this direction. So here resistor will be there. These resistor will get heat energy. That means the electrical energy is converted into heat energy. The electrical energy is converted into heat energy. This relation is given by Joule only. What is that? According to Joule's law, we will say the amount of work done is directly proportional to the generated heat energy in the conductor. Yes or no? So the amount of work done is directly proportional to the amount of heat energy in the conductor. Amount of heat energy. So W is proportional to Q. Right? So that's what here W is equal to J into Q. You know very well this formula. Correct? There is a relation between work done as well as heat energy. But heat energy here is speaking about electrical heat energy. Electrical heat energy. Correct? Where J is equal to joule constant. Therefore, J is equal to W by Q. Where W is equal, what is that? So, you know W is equal to all those things. Correct? W is equal to V is equal to, what is the formula? W by Q only in a general formula. V is equal to potential. Is the potential V is equal to W by Q. Therefore, I want to W. W is equal to V into Q. What is the meaning of V? According to Ohm's law, V is equal to I into R. I into R. Therefore, instead of V, we will consider I into R. I into R. Correct? Into Q. Into Q. Still this form we can write it according to this one also current formula also. What is current formula? So Q is equal to I is equal to Q by T. Next Q is equal to I into T. Therefore instead of Q we will write I into T. I into T. Correct? Familiar this formula we are. So instead of W, VIT. So W is equal to what is that? VIT divided by Q. That's joule heat. We will get with the help of calorimeter experiment only. Okay, joules calorimeter experiment, we will get Q value. Right? If you substitute VIT by VI potential difference. Potential difference we will get here. So current flow of current also you know already. So T also flow of current by time. Time also you know already. Q is equal, we will get with the help of joule experiment, with help of joule calorimeter experiment, joules calorie experiment only. So with help of that one easily we will get J value. This is J value constant. What is that? 4.18 joule per calorie. Joule per calorie. J value is equal to how much? 4.18 joule per calorie. That's why joule is equal generally. So you know 1 calorie is equal to 4.18 joules. J is the constant only. Correct? That is the, so 1 calorie is equal to 4.18 joule, like that we have already in the first year. Correct? So this is the one small formula, relation between W and Q. See, once you can observe there. According to Joule's law, the current passing through a conductor. According to Joule's law, the current passing through a conductor produces heat. Produces heat. The current is passing through conductor. It can produce heat energy. The quantity of heat produced, quantity of heat is Q, is equal to the work done by the electric field on the free electrons. Correct? The quantity of heat produced Q is equal to the amount of work done, the electric field on the free electron. That's why here W is proportional to Q. W is equal to J into Q, J W by Q I given. Right? Still, what is that? If constant I, that means current, constant current is passes through a conductor, for time t and potential difference V. Potential difference V, then work done in the time t is, work done by the time t is. So what is the formula? W is equal to V is equal to W by Q. W is equal to V into Q. V is equal to what? Q is equal to I into T. That's the formula we got. W is equal to VIT. W is equal to VIT. Are you clear? Right. Right. So what I have given there? So W is equal to VIT. Correct? So formula, what formula I have given? V is equal to W by Q. W is equal to V into Q. So Q is equal to I into T. This is the W formula. Alright? And I told W is proportional to Q only, right? Therefore, Q is nothing but heat energy only. That's what here. So we will give you, that is the current is flowing through conductor. It is a produces heat energy. That means that is a thermal energy. So that instead of W we will consider as a Q is equal to W is equal to Q. W is proportional to Q. So Q is equal to VIT. VIT thermal energy. The electrical energy is given thermal energy. So now you can observe here. According to Ohm's law, V is equal to IR we know. Correct? So Q is equal to V is equal to I into I square into R into T. One of the most important formula here. So that we will give you factors. Q is proportional to I square. The flow of current is more mean. The heat energy also more. Similarly, Q is directly proportional to resistance. Resistance is more mean. So energy also more. Similarly, the flow of current time. Time can increase mean heat energy also can increase. Correct or not? Through bulb. For example, here one of your bulb we are having. So here this is the resistor. Is the resistor. So this is the cell. Right. So now I have given. So only just 1 second. 1 second what happened here? The bulb will get little bit heat energy. If I give 2 seconds, it will more little bit more. So 3 seconds or 5 seconds mean it will get more amount of heat energy. Correct? That is why here Q is directly proportional to T, Q is directly proportional to resistance, Q is directly proportional to R square. Q is directly proportional to R square. This is the Q. Okay. So Q is nothing but heat energy. Heat energy, that means thermal energy. The thermal energy is given by work. So what is that? Cell only. Correct? The rate of doing, the work done by electrical cell. That means electrical energy is converted into heat energy. The electrical energy is converted into heat energy. So that W is equal to I square into RT. Here this is the W is nothing but electrical energy. E also, right? W is nothing but work. Work we can write in the energy term only. Energy is equal to I square into T. Similarly, so many formulas. What is that? E is equal to VIT. VIT. Okay. Next, SI unit of energy. SI unit of energy. Electrical energy. So general formula is joule only. General SI unit is equal to joule only. Correct? So now or else we will give you here the, what is that? E is equal to VIT. Right? What is the SI unit of V? Volt. Volt. What is the SI unit of current? Ampere. So time is equal to second. Okay, volt ampere into second is the SI unit of energy, means joule. Joule is equal to, we can write it, volt ampere into second. Right, dimension formula, everything we know. This is the electrical energy. Electrical energy. Still also you know what is that? So power related formula. So what is that? Power is equal to work done by time. Power is equal to work done by time. Correct? So work is equal to, that means energy is equal to P into T. P into T. Right? P into T. So power is equal to, what is the formula? So what is the SI unit? Watt. Okay, into second. So SI unit of work done is equal to joule. Correct? One joule is equal to watt into second. Are you clear? Joule and watt relation. 1 joule is equal to 1 watt into 1 second. 1 second. Correct? So that is the small relation also we know. 1 kilowatt hour. Yes or no? 1 kilowatt hour. 1 kilowatt hour. So in the first we learned, right, in the work power energy, 1 kilowatt hour is equal to what? This is the unit of power or joule, power or energy? Is the unit of energy, right? Yes or no? So kilo means 1000 and 1000 and watt into hour. Convert into second. 3600 seconds. Correct? So 36 into 10 power 5. What is that? Kilo. Yes or no? So this is the joule only, na? Watt into second. Watt into second. Watt into second is nothing but joule. So 1 kilowatt hour is equal to, what is that? 1 kilowatt hour is equal to 36 in 10 power 5 joules. 36 in 10 power 5 joules. Right? That is a kilowatt hour relation. So this is the electrical energy. Still, right. So one more small example. What is that? If number of appliances of wattage, okay, W1 comma W2 comma so on etc. So wattage been, you know already. What is nothing but, so the bulb or any electrical appliances is having some wattage, that means printed value, printed power value. So for example 60 wattage 60 candle bulb, yes or no, 40 wattage tube light, correct? Like that will be there. That is the wattage. Wattage is nothing but any bulb. So for example 60 candle bulb, like that will be there, yes or no? So tube light. So tube light, how much wattage will be there here in printed? Here is a printed, so 40 watts, like that they will write. They printed on the bulb. That is the wattage. Wattage is a printed value. That means this bulb value is that much wattage it can consumes. That is the meaning. Alright, okay. So if your number of appliances of wattage W1 comma W1 etc. are operating for hours, H1, that means first 1 hour, second hour, third hour, H1 comma H2 comma etc. Right, W1 can use H1 hours, and W2 electrical appliances wattage we can use up to H2 hours, like that only is the wattage. This is the time. Respectively, at the specified voltage, the electrical consumed in their operation, electrical consumed is equal to how much? So we can represent formula E is equal to W1 H1. That is nothing but power is equal to work done by time only, na? Same formula, W is equal to P into T. P is nothing but wattage, T is nothing but time only. Alright? So W1 H1 plus W2 H2. Second one, this is second electrical appliances. Next third, fourth, so on like that. Therefore, total summation W into H. So that the practical units of electrical energy in kilowatt hour we know. So that energy we can write it here in kilowatt hour. So summation WH is the wattage value. Okay, wattage value as well as time only by 1000. Remember here we have to divide by 1000. Why? Because kilo 1000 get cancelled, no? Yes or no? Kilowatt hour. So kilowatt hour is the unit. Kilowatt hour is the unit of energy. That means this is the, so joule only. 36 into 36 10 power 5 joules only, this value. Are you clear? So this is the units. Kilowatt hour is the units, number of units. How many units we are consumed per month? In that case we have to use this one. What is that? So number of units here, energy is nothing but number of units only. Number of units is equal to, so summation WH by 1000. Right, per month we into 30 days. Right, based on that one problem also we are familiar, class 10th also. Just I can revise one problem. What is that? So let there 4 tube lights, each of 40 watts. Each tube light is having how much wattage? 40 wattage. In the house, these are used an average for 5 hours per day. For a day, how many hours we are using the tube lights? 5 hours. In addition, let there be an immersion heater will be there. That wattage is 1500 watts. That watt is how much? 1500 watts. So every day we are using average 1 hour per day. per day, 1 hour we are using. Then how many units of electricity are consumed? How much? How many units of electrical energy is consumed? Okay, energy you can represent units only. In month, find the cost of consumption in month of 30 days at 80 paise per unit. 1 unit cost is how much? 80 paise. Alright, so now energy. What is energy? Total summation WH by 1000 into 30 days into kilowatt hour is equal to units. We can write it units. Kilowatt hour is equal to units. Okay, therefore, so this is the energy mean number of units. This is number of units. Okay, E is equal to summation. How many tubelets are there? 4. Each tubelet how many watts? 40. How many hours? W into H, right? Time is equal to how many hours? So per day 5 hours. Plus another will be there. What is that? So immersion here, how many will be there? 1 hour. That is 1500. How many hours? Per day 1 hour. Divided by 1000 into how many days? 30 days. Okay. Therefore, 4 5 are 20. 800 by 1500. So how much? 2300. Correct? So 2300 into 30 days divided by 1000. So 1 get cancelled. Therefore 3 3 is 9, 3 2 is 6 units. Alright, that is the energy. So cost. So cost is equal to how much? How many units? 13, 69. Each cost how much rupee? 80 paise. Correct? So 80 paise mean 0.8. Correct? 0.8. So now you have to do calculate. How much will come? 80 paise can take. Afterwards I will give that is 0. Then 8 9 ja 72. 8 6 ja 48. Correct? So how much will come? So 5. Right? 55. That is. Are you clear? So rupees how much? 55.2. That is the cost. Like that we have to use and we can solve this problem. This is the general formula only. Alright, okay, this is the about energy. Next we will enter into power. Right, so next electric power. So what is the meaning of electric power? Electric power, energy I have given. What is energy? The rate of doing work. The energy means the capacity to work. The capacity to do work. That is I have given. Now power, electric power. Electric power is nothing but the rate of doing. The rate of doing electric work. Correct? So the rate of doing work by electric cell. Electric cell, or else the rate of doing electric work is called electric power. Yes or no? The rate of doing work is nothing but generally power only. But here we are using electric power only, right? That is why here the rate of doing electric work is called electric power. Electric power. Here we will give you two types. One is, so the power given by battery. Next one, the power supplied to battery. Power given by battery, power supplied to battery. Correct? For example, if I consider this one, you can observe there. What is that here? The current is moving in this direction. This is the discharging cell only. Correct only? Na? Discharging cell. Discharging means power given by battery. Power given by battery. Work done by cell. This one. Work done by cell. That is the work done on the cell. That is work done on the cell. Correct only? So this is the work done by cell. Discharging cell means work done by power given by battery. Power given by battery. Therefore this is a V, this is a V, this is the 0. This is a lower potential, right? This is a higher potential. Higher potential. So current is flowing in this direction. So that power supplied by battery. Power supplied by battery. We can write it. What is that? Work done by Q. Work done by Q. General formula. Potential. What is the potential formula? W by Q only, na? So therefore W by Q is equal to V minus 0 is equal to V. Yes or no? Correct. Therefore W is equal to V into Q. Now power formula. Power is equal to work done by time. Work is equal to what? VQ. So VQ is equal to IT. IT divided by T. TT get cancelled. Therefore VI will come. So that here P is equal to VI. So this is, we can call it, what is that? Power given by battery. Power given by battery. Power given by battery. Next one here, power supplied to battery. Power supplied, charging by charging cell. Charging cell. Correct? So now, so this is the V and 0. So now work done by Q is equal to 0 minus V. Given, correct? By the on the cell means we will consider as a minus. So 0 minus V is equal to minus V. So W is equal to minus V. Q is equal to I into T. VIT. Therefore power formula. So P is equal to work done by time. TT get cancelled. Directly will give you P is equal to minus V into I. V into I. This is a negative. That's why we are calling this is power absorbed by battery. Power absorbed by battery. That is the power given by battery. Alright. Some formulas you can observe here. Power is equal to, what is that? VI. So V is equal to, V is equal to I into R according to Ohm's law. So I into I square into R. This is, we can consider, so in series combination. This formula we have to use for series combination. In series combination, so I is equal to constant, right? In series combination, current is constant. That's what here in series combination purpose. That means the electrical resistances connected in series combination, then bulbs are connected in series combination. In that case, we have to use this formula. Alright. Next, so power is equal to V into I. Instead of I, we can write it to V by R. V by R. So V into V square by R will come, right? So here V is equal to constant. V is equal to constant means that is a parallel combination. That means in parallel combination we have to use a formula, this one. P is equal to V square by R, right? Okay. Next, S side of power is equal to watt only, right? This is the watt. Joule by second. Watt is nothing, joule by second. S and dimension for everything, Next one, commercially we have to use horsepower. Horsepower. 1 horsepower is equal to 746 watts. Correct? So is a commercial purpose, you have to use power unit. Right? Okay, next. Right, based on energy, I have given three problems also I have to see. First one, what is that? Find the energy dissipated. Find the energy dissipated. What is that? Given question is, so here resistor will be resistant is equal to R is equal to 2 ohms is given. I is equal to 3 amperes. So time is equal to 2 seconds is given. Find the, so energy dissipated. E is equal to what? That is our question. Therefore formula, E is equal to I square into RT, right? I is equal to how much? 3 amperes. 3 I square means 9. 3 square means 9 only, right? R is equal to 2 ohms. T is equal to 2 seconds. So 36 joules. Finish. Next, second question. Find energy in 2 seconds. Find energy in 2 seconds. Given circuit like that is given. Here I is equal to 2T is given. 2 into 2T amperes. And resistance R is equal to 2 ohms is given. T is equal to 2 seconds. 0 to 2 seconds. 0 to 2 seconds. This is a variable power, variable time. The 2T variable current only, right? Variable current only. Therefore, we want to follow integration only. Therefore, E is equal to I square into RT. Therefore, dE is equal to I square R into dt. Correct? Integral. So, I square into R into dt. So, integral where to where current value. So, 0 to 2 seconds. I is equal to how much? 2T. 2T means 4T square. 4T square R into dt. So, what is the constant? 4 and R only, na? So, R value how much? 2. So 4 into 2, 8. Alright, 4 into 2 into integral t square into dt. T square into dt, 4 into 2, 8. So, integral t square dt. So, t cube by 3 only, na? T cube by 3. So, limits. How much limits? 2 and 0. So, 2 cube in 8. by 3. 8 8 is 64 by 3 joules. That finished. Next problem. So in the given circuit, find energy spent in 3 seconds. Energy spent in 3 ohm resistor in 3 seconds. 3 ohm resistor in 3 seconds. Similarly, energy spent complete circuit in 3 seconds. How much energy can spent in the complete circuit? Again, how much energy can spend in the 3 ohm resistor? 3 ohm resistor, correct? So now first we have to get equivalent resistance, total EMF, total equal resistance. So this is a series combination, this is the parallel combination. Therefore R equivalent is equal to series combination R plus this is parallel combination, R1 R2 divided by R1 plus R2. R1 is equal to 3, R2 is equal to 6 divided by 3 plus 6. This one formula, did you remember or not? R is equal to R1 R2 divided by R1 plus R2. This is the RP, this is the RS. So total R equivalent is equal to RSO plus RP. RS plus RP. RS is equal to 2 ohms, RP is equal to calculation. This one, 3 into 2, this one. So 3 3 ja and 3 2 ja. Correct? So 2 plus 2, 4 ohms. That is I got. So now current I don't know. Current value I have to find it. I is equal to how much? Therefore I is equal to formula V by R. V by R. V is equal to 12 volt and R is equal to 4 ohms. So 3 amperes. I got. I got. Yes? Okay, next. Question asking first what is that? Energy in 3 ohm resistor. E mean energy, not EMF. E mean energy, 3 ohm resistor. So formula, E is equal to, if I take this is I1, this is the I2, this is the I. Okay, na? I1 square into RT, we know formula. Correct? So that I want to I1. For I1 purpose, formula. What is I1 formula? I1 is equal to R2 by R1 plus R2 into I. R2 is equal to 6. Next R1 plus R2, 3 plus 6 is equal to 9. Into I is equal to 3 amperes. Okay, now everything is substituted. 3 3 ja, 3 2 ja, 2 amperes we got. 3 amperes we got. Are you clear? Then here I1 is equal to 2. 2 square means 4. R is equal to how much? R is equal to 3 ohms. 3 ohm resistor. Time is equal to how many seconds? 3 seconds. So 3 seconds. 3 3 is 9, 9 4 is 36 joules. Finish. Next one. So total energy spent in the circuit. So from the same formula, what is that? E is equal to I square into R. I square value is equal to how much? 3 ohms. 3 ohms, so 3 3 is 9. R is the total resistance is equal to how much? R equal to Nina. So 4 into T is equal to 3. So if you do calculate answer 108 joules. Or else E is equal to VIT formula. V is equal to how much? 12 volt. I is equal to 3 amperes. T is equal to 3 seconds. So 3 3 ja 9, 9 4 ja 9 12 ja 108 joules. Right? This is right. Next. Right. So now bulbs in series combination as well as parallel combination. May resistors are in series combination and parallel combination. In the series combination, power is equal to how much? In parallel combination, power is equal to how much? That is the next topic here. So, for example here, first example I will give you. So, how many resistors? N resistors are there. How many resistors? N resistors. So, for example, in this manner, so in this manner, in this manner, like that, so many resistors are there. Each resistance value is equal to R dash is equal to R only. Each resistance value is equal to R. How many resistors are there? N resistors are there. Therefore, R equivalent is equal to formula N into R. Correct? N into R. So now power is equal to series combination for power formula P dash or else PS. Series combination. Series combination general formula V square by R equivalent square. Equivalent square. Correct or not? Why? Because N cells are there. N resistors, N bulbs are there. N bulbs are, each bulb resistance is equal to R. Connected in series combination. Therefore, power is equal to power formula V square by R. This is the general formula we have to use for series as well as parallel. Okay, then now, so PS is equal to V square, RS is equal to how much? N. Correct? So sir, here RS only. R equivalent only. V square by R only. So R equivalent is equal to what? N into R. Alright. V square by R is equal to how much? V square by R is equal to P, right? Therefore, PS is equal to, we can write it to P by N. This is the series combination formula. Similarly, parallel combination. Same resistors we should connect in parallel combination. Therefore, RP is equal to, formula R by N, right? 1 by R plus 1 by R plus 1 by R plus N times. So RP is equal to, R equivalent is equal to R by N only. Therefore, PP, parallel combination. So what is the formula? V square by RP. V square by RP. Therefore, V square is equal to V square only. RP is equal to R by N. N goes to numerator. So V square by R is equal to what? P. Therefore, N into P. N into P. Small relation here. What is that? PS is equal to P by N. PP is equal to N by P. N into P. Therefore, I want to PS by PP. Power in series combination, power in parallel combination. Power in series how much? P by N, okay, into 1 by PP. PP value how much? N into P. So PP get cancelled. Therefore, what will come? So PP is equal to N square into PS. This is a small relation. Power in parallel combination is equal to N square times of power in series. Correct? So in series combination, so power consumption is more. Sorry, in parallel combination, power consumption is more. In series combination, power consumption is less only. Correct or not? Power consumption is less. That is the one example. So next another example. So what is that? In series combination. In series combination, we have to use formula P is equal to I square into Ry, because in series combination I is equal to constant. I is equal to constant. Therefore, power is directly proportional to the R. Very, very important this one. So that means, so power is, resistance is greater mean, larger mean. So power also, power consumption also more. Okay, that means larger resistance can consume more power in series combination. In series combination. Similarly, in parallel combination, we have to follow formula P is equal to V square by R. Why? Because in parallel combination, V is equal to constant. V is equal to constant. Therefore, P is inversely proportional to R. P is inversely proportional to R. That means R is larger mean power is smaller. That means, so larger resistance can consume lesser power. Larger resistance can consume lesser power. Right? This is the resistance related topic. Next now, brightness of bulb. Brightness of bulb. Okay, we will see now. Right, so now brightness related topic only. So bulbs are series combination as well bulbs are parallel combination I will give you. So first bulbs. Bulbs are which combination? In series combination. So like that I have some bulbs. Okay, 3 bulbs I have, and also remember here I have given certain potential. For example 250 volts battery I have given. So this is the resistor value. Something will be there, I don't know that value. Correct? This is the resistance of bulb. So filament, correct? Tungsten. So this wattage they given already in the printed wattage. 100 watts bulb. This is the 50 watts bulb, and this is the 25 watts bulb, 25 watts bulb, right? And also in our Indian system household, correct? House consumes how much voltage for each house purpose. We will Indian system 220 volt only, correct only na? So we are using 220 volt, that is the potential. 220 volt potential we have to use in each and every bulb purpose only, correct? Then which one is having more brightness? Which one is having more brightness, as well as current also you can find it. In series combination, current is same only na? Current is the same only. Therefore, we want to follow formula. Which one? So P is equal to V square by R. General formula. Now I want to R1. R1 is equal to V square by. So this is the P1. So P1, first bulb, but this is the first bulb, is the second bulb, this is the third bulb. For first bulb speaking, I am speaking first bulb. Here this is the P1 mean not a. So what is the P1 is nothing but wattage. P1 is equal to wattage. So that power only na. So V square is equal to how much? 220. 220 whole square by 100. Similarly R2. R2 is equal to V square by P2 is equal to 220 whole square divided by 50. Similarly R3. So V square by P3. So 220 by 25. So obviously this is the 100, this is the 50, this is the 25. So obviously what will come here? So R3 is greater than R2 is greater than R1 will come, right? Generally also. Correct? In series combination, formula in series combination, what is that? P is equal to I square into R. That means P is proportional to R. P is proportional to R. That means, so both are proportional only. Therefore, here what happened? P3 is greater than, P2 is greater than P1 only. That means, so P3 means R3 resistor. R3 resistor, this one only. So that means third bulb is having more brightness. Third bulb is having more brightness. Therefore, so brightness is directly proportional to the resistance of a bulb in series combination. Directly proportional in series combination there. And also second one is parallel combination. Parallel combination. So what would be happen? So parallel combination here, first bulb and second bulb and third bulb, same values I took there. Okay, so same bulbs, right? I will consider in this manner. So parallel combination. So parallel combination, the same one here also, 250 volt. So this is the first resistor and the second resistor and third resistor bulb. This is the first bulb, this is second bulb, this is the third bulb. First bulb is 100 watts and second bulb is 50 watts and 25 watts. Okay, so current is I1, current is I2, current is I3, but potential is same only. So this is the, here also, if you know R1 value, R2 value, R3 value, series combination only, therefore R equivalent is equal to R1 plus R2 plus R3. So this value can calculate, mean R equivalent value will come. If I want I mean, so formula is V by R equivalent. V is equal to this one. Remember, V is equal to 250 by R equivalent. You will get I answer. Alright? Okay. So now here parallel combination. Which one is having more brightness? That is my question. Which is having more brightness? Which bulb is having more brightness? This is a 100 watt, this is a 50 watt, this is a 25 watt. Reverse only, right? Yes or no? So this is the 25 is having more brightness. So now which is having? Right. So here also same formula. What is that? P is equal to V square by R. Okay, na? So I want to R1 now. R1 is equal to V square by P1 only, na? V square by P1 now. So V is equal to how much? This is the 220. That is the Indian system, right? So, right. So how much will come? 220 whole square divided by P1 is equal to 100. Same only na? Same this values only will come. Same this values only will come. So now in parallel combination formula, in parallel P is equal to V square by R. V is the constant, therefore P is proportional to 1 by R. 1 by R. If R is greater, mean P is equal to smaller, mean brightness is less. Correct? R is greater, smaller mean R is smaller mean, so brightness is more. Power is more, brightness is more, obviously. Correct? Therefore, which one is more power will be there? Power is equal to R1. Power is equal to R1. Correct? So therefore, R1 is less than, R2 is less than R3. Correct? Yes or no? R1 is the very small value. Very small value. So R2 value is the next, R3 is the next. R3 is the greater value only. Correct? So that here P1 is greater, P2 is greater, P3. Yes or no? Reverse order only. Here P3 is greater than, P2 is greater than P1. Correct? There P1 is greater than, P2 is greater than P3. Why? Because P1 is having less resistance. Less resistance mean which is having more brightness in parallel combination. So brightness is inversely proportional to the resistance. Resistance is less mean that bulb is having more brightness. Resistance is more mean that bulb is having less brightness. That means this bulb is having less brightness. Here this bulb is having more brightness. Are you clear? So this is the bulbs are in series combination, bulbs are in parallel combination. Like that they will ask question, which one is having more brightness, which one is having more less brightness. Like that they will ask question. Alright, okay, next last concept. Right, so now very important application this one, maximum power transformer theorem. Right, what is that meaning? Right, we will see. What is that? Consider a device of resistance is capital R. This device resistance is capital R and a source of EMF is equal to E and internal resistance small r. This internal resistance is smaller as shown in the figure. Right. So what is the relation between capital R and small r? We will see. So now in this current formula, I is equal to E divided by R plus R only. Yes or no? We are familiar with this formula. I is equal to E divided by R plus R. Now power dissipated formula. What is power dissipated? Remember this one. This is the power dissipated formula. Okay, so power dissipated. So in series combination, power dissipated. In parallel combination, power consumed. P is equal to V square by R. That is the parallel combination formula. In series combination formula, P is equal to I square into R. Here power dissipated will come. Okay, so P is equal to I value how much? E square by R plus R whole square into R. So now both sides you can do differentiation with respect to resistance R. Okay, therefore dP by dr is equal to d by dr by E square into R divided by R plus R whole square. Correct? So now dP by dr is equal to different variable will be there. Therefore that is becomes 0. dP by dr is equal to 0. So now E square can transfer, that becomes 0. E square also. Correct? Then d by dr into R, this one transfer numerator becomes minus 2. Now this is the d by dt into uv formula. That is u, this is the u, this is the v. uv into d by dt of v plus v into du by dt. So now here This is the r. Again here is a d by dx of x power n only na. D by dx of x power n. Therefore n into n mean minus 2 into x power x mean r plus r whole power n minus 1. N value is equal to minus 2 minus 1 minus 2 minus 1 minus 3 into different variable only, right? This one more time we have to do differentiation. D by dr of r plus r. Okay, so this one you can transfer to this side. This becomes minus only. Correct? So dr get cancelled is equal to 1. 1 into this one, that one only. The transfer becomes minus. This is r plus r whole power minus 2. R plus r whole power minus 3 get cancelled. So here r plus r whole power minus 1 will come. That is, you can transfer to this side. Again transfer numerator becomes plus only. Okay, this is transfer this side, it becomes plus. Right? So minus and minus get cancelled. So 2 into r 2r into dr into d by dt this one dr plus d by dr into small r is equal to r plus r. So now dr get cancelled, 1 will come, but dr by dr, that is a different variable, that is a become 0. Right? 1 plus 0 is equal to 1. So 1 into 2r 2r. Here r to r transfer that side, 2r minus r is equal to r, that is equal to r is equal to r. That means external resistance value is equal to internal resistance. In that case, what would be happen? We will get maximum power resistance. Right? That means the power dissipated in an external resistance. Power dissipated in an external resistance is maximum if that resistance is equal to internal resistance. The power dissipated in an external resistance is maximum. When we will get maximum power dissipated, mean the external resistance is equal to, okay, the resistance is equal to internal resistance, r is equal to small r. In that case we will get maximum, what is that, power dissipated in an external resistance is maximum. Okay, maximum power dissipated we will get of the source supplying the circuit to the device. Alright, this is the maximum energy theorem. That means show that r is equal to small r. That is the question. Maximum energy theorem. Right? Okay. Right. Next concept is fuse wire. Fuse wire previous also I have given about fuse. Correct? So a fuse wire generally prepared from tin lead alloy. Tin lead alloy only, right? Correct? Tin lead alloy. Tin lead alloy. So here alloy is nothing but 63 tin as well as 37% lead. This is the combination of tin lead alloy, right? It should have low resistivity. This point is very important. It should have low resistivity and low melting point. Low melting point. This is the low melting point. Fuse wire is having low resistivity as a low melting point. Right? Okay, next. The fuse wire is used in series with the electrical installation. We have to keep this one in the series combination only and protects them from high current. Correct? Any so high current, high voltage in that time. So fuse will protect the our all electrical appliances. That is the very important uses of fuse wire. Right? So small formula you can observe here. Let R be the resistance of a fuse wire. We are having fuse wire, so that wire resistance is equal to R. The resistance formula R is equal to rho into L by A. A is A I have written here. So pi into R square. This is a fuse wire will be there like that. Correct? This is the thickness, radius, and pi R square. Pi into R square. And here power is equal to I square into R only. Power dissipated is equal to I square into R. Here H is nothing but Q by T, energy by time. energy by time. H is equal to power here, not a heat energy. Okay, so power energy is now I square into RT. So H is equal to Q by T. Energy per time. Energy per time is equal to I square into R. So I is equal to what is that? I square only. R is equal to rho into L by pi into R square. This is the equation number 1. Similarly, so if H naught is heat loss per unit surface. Heat loss per unit surface. So area of the fuse wire, then heat radiated per second is H naught into 2 pi into R into L is the surface area. Surface area H naught. H naught is nothing but loss per unit time. Loss per unit surface. Loss per unit surface. Therefore, H naught into 2 pi into R into L. So this is the equation number 2. So here this formula, total formula is what is that? Heat radiated per second mean H by Q. Sorry, Q by T. So here also Q by T will be there. Here also Q by T will be there. So from 1 and what we can write here? So H naught 2 pi R into L is equal to I square rho into L by pi into R. L get cancelled. Therefore H naught is equal to I square rho divided by 2 pi square into R cube. Right, equation number 3. According to Newton's law of cooling. According to Newton's laws of cooling, because this is a heat chapter only, this is a heat related topic only, right? That's what we enter into Newton's laws of cooling also. So that according to Newton's laws of cooling, so what is that? The heat loss per unit surface is equal to K into theta. K is equal to constant. Theta is equal to increase in temperature. Correct? So now equation 4, equation 3, what we can add theta? So K theta is equal to this and all, right? I square rho divided by 2 pi square into R cube. So K transfer this way, K will come. Therefore, this is the our increase in temperature formula. How much temperature can increases in the fuse wire. So that is the theta is equal to I square rho divided by 2 pi square into R cube into K. Correct? Temperature is direct proportional to the I square and direct proportional to the resistivity, inversely proportional to the what is that? R cube radius. And this constant, right? I square is proportional to R cube also relation, I square and R cube. Are you clear, ma? So this is the power related topic, right? So small concept I will give you, right? Last topic in this session, ma. This is the what is the long distance power transmission. Okay, so long distance, yes. So power we can transmit so long distance only, right? In that case, what happens? Some power loss can form. Some power can loss should be happen. That power loss, how can we will control? That power loss, how can we will control? That purpose on this formula, right? When power transmitted through a power line of resistance R, the line resistance is equal to capital R. Power loss will be PL is equal to I square into R, power dissipated formula. What is that? So PL is equal to power loss is equal to I square into R, equation number 1. Then let P naught is the power transmitted at voltage V. Okay, P naught is the power transmitted at voltage V. Then P naught is formula V into I. Correct? So now I want to I is equal to P naught by V. So equation number 2. So from 1 and 2, what we can add here? PL is equal to I square P naught square by V square into R. Therefore, here P output P naught and R both are constant. Therefore, PL power loss is inversely proportional to voltage. Correct? That means if we send with the high voltage, power loss is minimum. This is a very important. That's what here the wires are having so very high voltage. The power lines are having, the wire is having very high voltage. That's why in the telephone, terminal, what is that? That poles, yes or no? That poles, they will make their one mode. What is that? This is the high voltage poles, like that only. High voltage power poles, like that they've written. That's what very dangerous that is. Okay, now, right? If power transmitted at a high voltage, power loss will be small. power loss will be small. That is a very much useful for us. Power we can lose less mean, so we'll get more power, right? Okay, now efficiency of power. Efficiency of electrical power, we can represent eta is equal to P output by P input. P output is equal to VI, P input is equal to VI plus I square into R. Is the efficiency formula. Therefore, you can observe here at generator, so P input is equal to VI plus I square into R. So going like that only. So at home, so P is equal to, this is the consumers. We will consume this much current. This is the power, so dissipated. Yes or no? Power generated here. How much? So VI plus I square into R. This is the power concept, man. Okay na? So next class we will discuss another topics. Right? Thank you to one. Thank you.